started now. Okay, so okay, go ahead with continue with your explanation of this. So
Okay, so
you
the
said,
level of
I said
significance of
the first step is to define the hypothesis, yes, which you have
yes.
done. Step two, the significance
So
level, yes,
the significance level I used was 0.05. So
5%, okay, yes,
so the test I used was ANOVA test, single factor ANOVA test.
single factor ANOVA test. Is there a
That's what
particular reason why you chose single factor ANOVA test?
we can't use two factor ANOVA test because it's just we don't have to. I don't really know how to put it, Sha, but I don't think we have two
Oh,
variables or something like
oh, okay, okay, no problem. Go ahead.
that. I
So,
did my analysis using that test and I got my p value. Value I
okay,
got was 0.58.
0.58. Okay,
5817. That's what I got.
0.58.
51763. That's what I got.
5817 something, right?
Yes, 17 something.
Okay, so
So when I got this, it now shows that is higher than significant level, which is 0.05.
yeah,
Therefore,
therefore,
I now accepted the null hypothesis, which says that there is a relationship between the car wash and restaurant.
okay, so,
Meaning that for everybody that comes to wash car, about two or three or more person or less also bought food from the restaurant. So,
okay, okay.
and I
Yeah,
rejected the alternative hypothesis.
you rejected the alternative, right? No, no. When you are concluding, you always focus on the no. What did you do to the no? You retained it, right?
I accepted.
No,
Okay, I retained it. Yes.
yeah, better you say retain. Some people say
Okay.
accept, but retain makes more sense because the null has been there all this while, right? Like I said, as I've always said that the null hypothesis is actually the status quo, okay? The state of things ever before um, the alternative hypothesis was proposed. I don't know if you understand what I'm saying. So that's why you retain it. You don't accept it. It's not new. What is
Okay.
new? What
Okay.
is new is the alternative hypothesis. I don't know if you are getting
Okay,
the
sir.
point.
Yes,
People use
yes.
the word
Yeah.
accept. People use it, but it's not. That's what I'm trying to explain why it's not appropriate. Okay, let me give you an instance. For instance, let me use the example I often use. Let's say a drug, let's say like HIV, right? Somebody comes up and says he now has a cure for HIV, and then comes up with the drug and all that, and it's to be subjected to a test. What will be the null hypothesis? The null hypothesis will be that that drug cannot cure HIV, right? That will be the null. Why? Because up until now, we know that there's no cure for HIV. So that's the null. Okay. So if at the end, after all the analysis, your p-value is high like this, which means we are doing what? We are
Well,
retaining the null hypothesis, which has been the situation ever before you propose this hypothesis. I don't know if you are getting me. Okay, do you get my point?
yes, sir. Yes, sir.
Yeah, that's why the word retains is more appropriate than accept. Okay, the word is new. There is the alternative that says it can cure HIV. That's a new thing. The null is what has always been. Okay, anyway, that said, any other opinion before we discuss this? I want us to discuss it in such a way that this is a very practical problem. Any others? Any Mr. Stewart, thanks for what you have shared,
Thank you, sir.
for the courage. Yeah. Okay. Any other opinion? Any other solution? It's better to try and miss
Well,
it
for me,
than not to try at all. Yeah.
Let me just take it from where I stopped.
Mm.
For me, I look at this test from the T statistics test of mean
Okay.
uh,
Okay.
area. That's where I pick it from.
Okay.
And I'm looking at the parameters that are given for both of them. The counts are less than 30. So, they fit into the statistics environment. I mean, the test of mean environment. And I'm looking at two samples, assuming on equal variance.
Okay.
Okay. Are you there, sir?
Yes.
Yes.
I can hear you. I'm with you.
I'm looking at it from two samples on equal variance
Okay.
tests.
Okay.
Yes. That is the angle I'm looking at it from. And, so that is my test criteria that I use. So I'm looking at either
Your test criteria.
the relationship I'm looking at there, if the restaurant is equal to the restaurant is equal to that of the car wash,
Yeah.
or the car wash is equal to the restaurant.
Yeah.
That is talking about the setup of the hypothesis. So sorry, maybe I should have started from there.
Okay.
Yes, is equal to, or on the second hand, if the restaurant is less than or equal to the car wash, or the car wash is greater or equal to the car wash. So those are the hypotheses I'm trying to deduce from this. And from what I can see here, if I don't know if I'm correct, looking at the p-value here, I don't know if I'm correct. Yeah, I'm looking at the p-value, which is zero for me. It's 0.29095 which is quite higher than
which is also high.
alpha.
Which is also high.
High.
It's high.
Yes, compared to the alpha.
Okay.
Yes, so it's higher than the 0.05.
Okay.
And in that regard, it's higher.
Okay. All right.
So maybe you want to take it from there, but so I shouldn't be speaking jargon. So please take it over.
Okay. Thank you. Thanks for. Yeah, I actually prefer to hear us speak like this, because that helps us to easily put things in perspective. Like I said, and I'm serious when I say that, it's always better to attempt, even if you miss it. The fact that you attempted, there's something it does to you. It takes you to another level, by the time the correction is done. Okay, first of all, I want to draw attention to something that if you look at this, first of all, I gave you one hint. Who can remember the hint I gave? Do you remember the hint I gave before we started?
Besides the numerical data.
I said it was what? I don't think that's what I said. What was that hint I gave again? Okay.
So what
I
are we
said,
looking for?
yeah, no, I said you should consider the type of data you are dealing with. Do we remember that?
Yeah. Yeah.
Yeah, I said
Yes.
you're solving problems in analytics. The first thing is to look at the type of data you are dealing with. Look at the type of
Exactly.
data. Yes. That's why you see in the course of our study, we dealt with types of data. We talked about numeric, continuous, categorical. Under continuous, we had ratio, we had interval. The under categorical, we had nominal and ordinal. I hope we remember that. Okay, so these are different types of data. Okay, and I said consider the type of data. So now, when you consider the type of data, then it just rules out that streamlines your options. Okay. For instance, t-tests and ANOVA tests, which are very popular tests, but they are tests of mean, isn't it? Okay.
Yeah.
Yes.
They are tests of mean. They are tests of mean, and mean is mostly applicable when you are dealing with what? Numeric data,
It was.
isn't it?
Yes.
Numeric data. Okay. But if you look at this is not numeric data. This is not
Yes.
continuous data. This is ordinal data.
Hmm.
This is ordinal. Hope you know. These are ranks. What's on the ordinal data? Do we remember what ordinal data is? Ordinal data is what we use for ranking. Hope we can remember that.
Okay.
When we talk about ranking, ranking is ordinal. Ranking is ordinal data.
Okay.
Okay, you are dealing with ranks, even though they are numbers, but they are not absolute numbers like that. They are not like ratio. Okay, they are just ranks. It's just like ranks in an exam. Say somebody took first, and that person took second, third, fourth, and so on. But that first, second doesn't measure. It doesn't tell you by how many marks this first guy, exceeded the second. It doesn't tell you how many marks are in between. Okay. This one may have been 90%. Maybe this one is 90%. Maybe this one is 75%. And maybe this one is 74. While between this and this is maybe about 15 marks. But between this and this is just 1 mark. So you see, it doesn't tell you exactly how close or how far apart the actual marks are. It just simply tells you the positions. That's the nature of ordinal data. Unlike numeric data. If it were numeric data now, let's say we capture scores of students. Okay, 45, 65, 78. These are scores. Assuming these are scores of students. student scores now in a test. Now, these are absolute measures now. If you look at this, it's telling you exactly, let me put 90 here so that I can illustrate something. This is telling you that whoever has this had performed double of this. Okay? Are you following me? You are able to see the difference in marks clearly. But if you are to rate them with position or ranks, this will be number 1. This will be 2. This will be 3. This will be 4. Okay. Now, let's sort this one so that you can see what I'm talking about. Sort it the other way around. Okay, so you see now, while there are ranks or position, while rank is just giving you the impression of 1, 2, 3 with intervals of 1, 1, 1. But the actual scores, I mean, they differ. Between this and this is about 12 marks. But position difference is just 1. Between this and this, the gap is different from this and this. This is about that's 30 something marks, but the
33, yeah.
but the gap here is just like 1. Are you following me? So
Yes.
ranks does not give you the full details regarding the spacing or the relative values. That's the nature of ranks. That's why the models that are amenable to numeric are sometimes not appropriate or ordinal. You understand? T-test and ANOVA test are suitable as test of mean when you are dealing with numeric data. Okay, so in this case, well, we just to go through the route of hypothesis testing. Yes, you could do that if you like. You can do that. You can do that actually, but you can just go straight to apply a model, because what you are asking for, the key word here is what? Relationship. That's the key word there. Am I right? That's the key word. The key word here is there a relationship? Is there a relationship?
Yes.
And that talks about correlation. Okay? Talks about correlation. You are asked to measure a relationship. Okay, let's look at this. Let's talk about t-test and ANOVA. Let's see the difference. T-test is otherwise called what? Is what? A test of what?
Mean.
Yeah, what about mean? Test of difference of mean. I want us to qualify it clearly so that we'll see. Of mean. Okay, so t-test is used to test if the mean of two variables are the same or if they are different. See, test we simply call it test of mean, but if you want to, because of what we are doing now, that's why I want us to qualify it fully. It's actually a test of difference of mean, isn't it? test of difference of mean. Same with ANOVA. ANOVA, the same thing. ANOVA is also a test of difference of mean. Of mean. That's what ANOVA is used for. ANOVA and t-test. It's just that one of the differences is that ANOVA can handle more than 2 or more samples, but t-test is limited to 2 samples. Also, ANOVA is limited to independent samples. Okay, now let's go back to our problem. Now, I'm just trying to clarify these two so that these are very popular tests. So sometimes we quickly think about them. Now, let's compare this with correlation. We can define correlation. What's correlation? What did you say correlation is when we dealt with correlation?
Correlation,
Yes.
he said, is used to determine the strength of the relationship between.
Thank you. Thank you. Thank you. Says a measure of the strength and what again? Direction of the relationship. You see the keyword now. Relationship between variables. You see that keyword? That's why I said that is the keyword. In fact, from the definition itself, just spells it out. Correlation is a measure of the strength and direction of the relationship between variables. Now let's go back to the question. The question says, given the data on the left, does there seem to be a relationship? Are you seeing the connection now?
Yes, sir.
Does there seem to be a relationship between the level of customer satisfaction with respect to the company's restaurant service and car wash service? Explain analytically the reason for your opinion. So, what you need to do here, is simply to just compute the correlation. Okay. So if the correlation is high, then there's a strong relationship. If the correlation is low, there's a weak relationship. Okay. So let's say you have a correlation of like 80-something percent, 90%. Okay, that's a measure of the strength of the relationship, especially if it's positive. If the correlation value is positive, it means that those that are satisfied with restaurant are also satisfied with car wash. But if your correlation figure is negative, it means that those that are satisfied with this are not satisfied with the other one.
It's actually weak correlation. That's what I actually did, sir.
What? That's what you got.
That's what I did. Yeah, it's a weak correlation.
What did you get? What's your figure?
I got minus
0.6.
0.6 29 74.
Okay.
70.
0.6. 0.6.
Minus.
Okay.
Minus
Minus 0.6.
Minus. That tells you that is negative. That's not a good one. That shows those that are satisfied with one of the service are not satisfied with the other.
Not satisfied with the other.
So there needs to be a research into that. Why is it like that? Okay. Why is it like that? Is it that there's some sort of struggle between the staff that work in those departments? Are they dragging for customers and thereby causing problem, for the cause? Something like that. That needs to be checked, because that's abnormal, very abnormal for it to be opposite. Then also, they need to now check properly, maybe the staff in one of the two sections are not rendering good satisfactory service. Okay, of course, the actual rating themselves should also be looked at and all that. Okay, so but one more thing you must take note of, because I'm going to explain the solution, but I'll leave you to go and solve it. Okay, that's what I'm trying to do. You'll still be the one to solve it. I'm just going to tell you what to do. Is that better? Is that okay?
It's okay.
Okay. So
It's
now,
fine, sir.
now something else you need to consider. Remember, I said explain analytically the reason for your answer. That's why I'm explaining all this. First of all, you are going to do correlation. Why? Because you are testing for relationship. That's one.
Relationship.
Secondly, you need to understand that you are dealing with ordinal data. Okay? And since you are dealing with ordinal data, don't forget there are two types of correlation. Do you remember? We dealt with two types of correlation. We dealt with the Pearson product moment coefficients. Do you remember Pearson? Pearson coefficient of
Yes,
correlation.
coefficient, yes.
We dealt with Pearson coefficients of correlation. We also dealt with what? Spearman. Remember? Spearman coefficient of correlation. Okay. So you need to know when to use which. When do you use which? That's the question. Now, Pearson coefficient is designed for numeric data. Spearman coefficient is designed for, that's why Spearman, in fact, Spearman, let me write it in full. Coefficients Spearman rank coefficient of correlation. So Spearman's coefficient is designed for rank data. Spearman coefficient is designed for ordinal data, right? Ranked. Okay. However, you can use you can decide to use the Pearson, but the one that is actually designed for it is Spearman. But if you use Pearson and use Spearman, most of the time you get values that are close. Okay, but the best option, what is actually designed for it, is the Spearman. Okay, but Excel, the one that comes with Excel is Pearson. Okay. So I'll do the Pearson, but I'll leave you to go and do the Spearman. Okay. So, okay, just like you said, this is giving a negative value. That's for Pearson. But I want you to go and use the one that is suited for it specifically, which means you have to do it by applying the calculation by yourself. Okay, let me share the. You remember the formula? Those are not things you should be struggling with. If you don't remember, just go online, just open your Google. You have to be used to that. As a professional, Google is your best friend. Look at it, Spearman rank correlation. That's the formula, just as a reminder. That's the formula. Do we need explanation for that?
Let's break it down.
Do we remember that formula?
Yes.
No, for me, I was in the class where you treated this thing. So this
Really?
particular,
Okay.
that was it. I traveled. That was when I traveled for almost 3 months.
Okay. No problem. Okay. So no problem. So see. You can see the formula, right? Let me explain it. This formula is saying this row here, look at this, Spearman's rank correlation coefficient. Okay. The D is the difference between the two ranks of observation. The N is the number of observations. Okay? Yes, so this is the formula. This D is the difference. Okay, you can write, just put it down first before we go to Excel. So, which means you need to get this D, right? The D. The D is the only unknown here now. We know N. N is 16, the number of observations.
Yes.
Is 16, and the value of N is 16. Is the D that we need to compute. So let me show you how you get your D. Okay, let's go back to the Excel. Let's move all this to the right. Okay, so here we are going to have D there. And you know we also need D squared, remember?
Yeah.
We need D squared. So let me put this as a power. Highlight that, right click, format cells, superscripts. We need D and we need why is it not staying? Okay, so now okay, so what is D? D is simply this minus this.
Subtract, yeah.
Yeah, so equals the rank in here minus the other rank. Okay, you copy that down. D squared is simply the square of D equals D to the power of what? 2. That's D squared. Okay. Then if you look at the formula is actually saying you should use summation D squared. Did you see that? That is sum of this.
Yeah.
Hope you let me display it again. Or do you have it there? Let me show you again. Now you see rho is equals 1 minus 6 summation d squared. Okay. 6 summation d squared. Oh, I'm just solving the thing. I said I was not going to solve it. But let me just continue with the hint. So that summation d squared is the sum of this summation of d squared. You're not seeing my Excel anymore.
Yeah, I'm not seeing yourself.
Okay, that's the sum of this d squared column. That's what summation of d squared means.
Yes,
Okay,
yes.
so we are going to have the sum of this.
So everything is as
Is
you
it?
have everything already.
Yes,
So go ahead.
so you have
You have
everything.
everything.
You already
Yeah.
have everything now. This is your summation d squared. So now you have everything, just to fix it in and apply the formula.
Yeah.
So, okay. So we just go ahead and do it.
Okay.
Or you want me to leave it to you as assignment? What's your choice?
Anyone they say. Whatever they say.